In this video, I want to look at attributes and properties. So, we've seen how attributes work with fields. Properties are another way of working with fields as well. But let's start with attributes. So, Python has this concept of attributes, and this is somewhat unique to Python. What you do is, instead of actually having to go through and define the field yourself explicitly, in other words, typing it out, you can have it automatically create the field for you. In other words, I didn't actually need to type in the field code to make it work. Now, personally myself, since I started off programming a number of languages that didn't have this feature, I typically will go through and add my field so it's visible. But you don't really need to do that in Python. So I will just comment it out and leave it there. And it will continue to work even without it. The interesting thing is that you can still refer to the field as if it was there. So even if it's commented out, I can still go ahead and set Susan's name. Let's see here. I'll go through and try this out, and I'll show you what I mean. I'll copy this. I'll come over to PyCharm, and I'll make a little test one to work with. Oops. New Python file, test. Paste in the code, and you can see that this is commented out. It's not actually being used. But when I run it, Sue actually gets set anyway. And the way I was able to get away with not using anything in the initialization of the object was by just setting a default value. So by going through and setting a default value for first name, I could choose either to include an argument for the constructor or not. And if I chose not to, for whatever reason, I could then go ahead and just use the field first name, even though it wasn't actually typed out. It was just implied by the use of attributes. Now again, this is a convenience. Python's creators assumed that you would be making these fields anyway, and you'd be setting the fields in the constructor. So the thought process was, if you're going to make this anyway, why the heck would you need to type it out first? Well, that's an interesting concept. I can understand that. For my idea about it is that typing it out where it's visible, very explicit, kind of defines what you're trying to do. It makes it a visual roadmap. However, I do have to say that whenever you add more code to a script, it takes longer to run. So the fact that Python is going to do this invisibly for you, if you left this out, it would save a very minute fraction of a second. I suppose if you were doing something really heavy, that might add up, but most of the time you're running Python as a script or set of scripts, and the performance is really not its main feature. So, in summary, attributes are a way of automatically defining a field. If you use them, you don't have to explicitly create a field before you go ahead and initialize a value for that field. It will automatically create one invisible to you. You saw that it would work if you did make the field, but it's not considered a best practice in Python to do so. So in my case, I just type it out and then just comment it out. And that way I get the best of both worlds. I get the visual aspect, but I'm actually using the attribute feature in Python. Now, something associated with fields and attributes is the concept of properties. What a property is a special type of method that allows you to go ahead and work with your attributes / fields. Let's talk about that. Oh, I got one more thing to say, I guess, before I move on to properties. One of the things that you often will do is you will make your fields private. And in Python, the way you indicate that the field is not supposed to be worked with directly is to add a couple underscores. Now this is 2 underscores, making it a private field. The concept of private fields is that outside of the object, you're not supposed to work with it directly. Let's see if I can elaborate on that. So we know that we're going to go through and we're going to make a we're going to make an object. Oops. So we're going to make an object from the person class. And the first name field can normally be accessed from your other script code. So you make a new object, and the first name field could be accessed from the basic script code that makes up well, your script, not the code inside the class. So this means that the field would normally be publicly available. In other words, it's available outside of working with the class. But if you flag it with this double underscore, it will mark it as private. Trying to actually set it directly will be ignored. And in some cases, if you get the combination just right, you might even get an error message. Python, of course, is really flexible, so they don't always give you an error message or anything and try to stop you from doing things that you're not supposed to. The way Python does it in this case is that it just ignores you when you try to set it directly. But in other languages, such as C# or VB or whatever, Java, you'd get an error message saying, hey, you can't set that a value for a private field. So why would you do this? Well, it has to do with the concept of encapsulation. You guys remember how we talked about abstraction and encapsulation? In other words, you want to work with things in the abstract by encapsulating them. And that's what you're doing here. You're making a capsule around the object, and the fields inside are inside the capsule. So first name is inside the capsule and can only be used inside that capsule. You can use it from the outside by working with a constructor when you go ahead and make it. So you pass arguments in, but once it's inside, you can't work with the data directly. Now the advantage of this is that objects, the individual objects that you make, are considered, well, individual. So I think 3 objects from the person class. I have 3 different objects, and the state data for first name is probably going to be unique. One's Sue, one's Bob, one's Tim, one's whatever the heck it is. And what you want to do is you want to protect your data. And you protect it by making people work with it in the abstract, by encapsulating it. That is a common design principle when you're creating classes. Make your fields private so that people can't work with the data directly. They have to work with it indirectly in the abstract. And you do that by encapsulating it, which is done by making it private. So if I take this code, actually I guess I don't need that code, I just need to modify my test code here. And right now I'll go ahead and put 2 underscores, oops, underscore, underscore. Now that has made a new private field, so I guess I should document that. And now I want to go ahead and change this as well. Get back there. Now this field doesn't look like it exists. So let's see what happens. Python ignored it. Let's put in the underscore. Python still ignored it. Interesting thing is we didn't get an error message. Let's try this. Kind of bizarre, huh? You would expect that if you had something that, well, just wasn't there, that Python would give you an error message and say, hey, you can't do that. But it doesn't. You know, this is one of the things I don't particularly like about Python. It feels very sloppy to me. Other people would say that it's very friendly, but who cares? It's just the way it works. So it's true that there is now a private field in there, but it just ignores you when you try to access it. We didn't see that behavior before we made it private. So we can see that the private feature is actually working. And the only way now to work with the field in the second object here, person2, P2, is to use the constructor. You can't go through the capsule other than through the constructor in this case, because the constructor is public. It's publicly available. It is a way of interacting or interfacing with the data inside of the object. Now, that is certainly an important feature, but what if you do actually want to work with the fields? Is there a way to do so? Yes, actually there is. You make public property procedures. Now these are basically like functions that are flagged as being properties. So these are property functions or property procedures. Procedure, function, method, all the same thing. Now the advantage of using this seems a little odd, but if you have a field, you can't put any validation logic on the field. Like I have a first name field. Can I put an integer in there? Yes. Can I put a string in there? Yes. A decimal? Yes. Boolean? Sure. There's no restriction in Python that stops me from putting whatever the heck I want into the field. And it's true that when I make the constructor, I can go ahead and put some validation logic inside the constructor that says check to make sure that nobody's passing in numbers into first name. That would be possible. But another way of doing it, perhaps a better way of doing it, is to go through and create these property procedures. And the way you do it is you define it just like a function, with the word self there, and then you interact with the field. Now, I don't have any actual validation code here, but if I did, it would be something like if it's true that, you know, first name this is actually reading the value, sorry. When you're reading the value, this is called a getter. You're getting the value or accessing it. You wouldn't put logic in there for like if statements, but you could do something like this. You could say, okay, let's change it to lowercase. We could use the lower function to change it to a lowercase value. In other words, we could do some kind of formatting code in there. When you set the value, this is how you indicate how you want to set the value. This is where you put your if statement here. So now I'd go through and I'd say, okay, if it's true that the name coming in is equal to, I don't know, something I don't want, a number. We have that, you know, those functions that we talked about in the strings like isDigit or isNumber. We could use those. Or check to see if it was a null value. We could put any amount of if statements in there to verify that the value coming in is within the range of values or the type of data that we want to put in here. And you simply can't do that with a field. And although you could do it within the constructor, the concept of making these property procedures, so you can actually put in your presentation code to format it, or your validation code to check the value, is considered a best practice, a better practice. It doesn't take that much more work either. So to add in a property, all you need to do is go through and add in that block of code. So in the property section, for each field I'm working with, or attribute I'm working with, I go through and add in a set of property procedures, one to get the data and one to set the data. And they have fancy names for these. These are called accessors to get the data and mutators to change the data, or the slang for it is getter and setter. Now, this is common in pretty much all of the object-oriented programming languages. I'm not using any validation logic. I'm not using any formatting logic, which is fine. You don't have to. But it does make it seem like it's extra work for no additional benefit. And that's true. I'm not actually benefiting by my ability to add more code in here, because I'm not adding more code. I'm not benefiting by the validation logic, because I'm not adding validation logic. But even when you don't add in formatting or validation logic, it's still considered a best practice to include a property procedure for both the getter and setter for any attributes. Why? Because it works with the concept of encapsulation and abstraction. These property procedures, they are public. Your field is not. It's private. And because they're public, we don't use underscores in front of them. But we do work with the private attributes. These are a way of interacting or interfacing with the object. So you have hidden or private attributes / fields and public properties to set and get the data. This provides a concept of abstraction and encapsulation when you're making an object-oriented program. Let's try that out in the next lab. Why don't you go ahead and test out how that works by going through and creating it. I'll see you there.